All right, so the next section in lesson 5 is glycation and reactive oxygen species. So this is going to be a very important part of this lesson that talks about the development of different AGEs, or advanced glycation end products, and reactive oxygen species that can lead to a lot of the tissue damage and diseases that we talked about in lesson number 4. So what is glycation? It's, in technical terms, it's the first step in the evolution of damaging molecules through a complex series of different reactions. They're listed here: Amadori, Schiff base, and Maillard reactions. These reactions take place when a simple sugar molecule, such as fructose or glucose, combine or attach to a protein or lipid without the moderation of enzymes. So really what happens is you have in the blood, you have a protein and you have your glucose molecule, and they come together and then they stay together. In a healthy individual, the protein and glucose will come together and then they'll detach after a short amount of time. In someone with hyperglycemia and type 2 diabetes, they're going to come together and then they stay together. And it's when they stay together that's the formation of what's called the advanced glycation end product. And that's when you can have all sorts of damaging effects throughout the body. And so because of the fact that these AGEs then will move throughout the tissues, causing a lot of damage. Here's an example of the formation of an advanced glycation end product, where you have, here is a glucose molecule here, and the protein is here, and it's just the combining of the two coming together to form advanced glycation end product. You also have the reactive oxygen species, or a free radical, that is a hyperactive oxygen molecule that can come in and help facilitate the combining of these two, the protein and glucose, together to make things easier, or make them combine and stay together. So you have the AGEs that can cause damage, and also the reactive oxygen species that can cause damage to the tissues as well. So why are we talking about this? Why is these AGEs and reactive oxygen species so bad for us? Well, here's just a simplified short version of the effects of AGEs, and in a moment we're going to talk about them a little bit more in depth. But first, you have glucose levels that rise, causing hyperglycemia, and there's going to form the enhanced protein glycation. And what happens is those products, those protein and glucose, are going to be taken up, and in the tissues you have now advanced glycation end products, the formation of a protein and of a glucose coming together. Well, these AGEs can cause all sorts of inflammatory signaling, and also recruiting reactive oxygen species to the tissues, and these can cause apoptosis of the vasculature, or of the microvasculature, the capillaries that feed the various tissues of the body, leading to nephropathy, disease of the kidney, neuropathy, disease of the nerves, retinopathy, disease of the eye, and also atherosclerosis, developing a plaque as well. So this is a linkage as to how hyperglycemia can lead to all of these risk factors that we've talked about and showed in lesson 4, but how those are actually formed. And this is just a summation of what we just talked about. Again, this is just a simplified version of the effects of AGEs that we're going to get to in the more involved pathway in just a moment. Here's a series of videos that we're going to go through that talk about the formation of AGEs, the roles of AGEs in diseases, and then how they can be measured. All right, so this is the first video that talked about the formation of AGEs.
AGEs are formed through two distinctive pathways. One is the classic pathway of glycation or Maillard reaction, and the other is the newly identified oxidative pathway. The glycation mechanism typically occurs when there is an elevated sugar level. The increase of glucose inside the body will result in a non-enzymatic chemical reaction between sugar and proteins. In the beginning, this is a reversible process, and several intermediate products could be formed within hours, days, or even weeks.
So what this video is showing is you have your protein and you have your glucose molecule. They're coming together to form that AGE. But you notice that in this case that some of them can detach after a short amount of time, which is normal. It's when they stay together for an extended period of time that it can then cause damage to the tissues of the body.
However, in the end, when the advanced glycation end products have been formed for several weeks, this process becomes irreversible. The newly formed AGEs can further cross-link with proteins and will remain in the tissues for years. The oxidative pathway occurs in the presence of oxidative stress or excessive reactive oxygen species.
So what's happening here is that you now have these free radicals or the reactive oxygen species, which again is just a hyperactive oxygen molecule that is coming in and it's starting to facilitate the binding of this protein and this glucose together. And also the reactive oxygen species themselves can cause damage. And the reactive oxygen species are attracted to the AGEs, as we'll show in just a little bit.
Highly reactive oxygen species can quickly become reactive dicarbonyl components, which will react rapidly with proteins, lipids, and DNA to form AGEs within an hour.
All right, so that was the first video that talked about the formation of AGEs. Now we're going to talk about the role of AGEs in the development of diseases. All right, so this is the video on the role of AGEs in the development of diseases and why they're so bad for our health.
AGEs affect nearly every type of cell and molecule in the body and can cause long-term damage to the tissues due to their irreversible formation and extremely long half-lives. The excess accumulation of AGEs will lead to faster aging and may accelerate the onset of many age-related diseases such as diabetes, renal failure, atherosclerosis, and Alzheimer's disease. In particular, AGEs play a pivotal role in the cardiovascular complications of diabetes and renal failure. In diabetic patients, the rise in sugar level will generally lead to an abnormal accumulation of AGEs. The excess of AGEs will accelerate the development of cardiovascular complications through the initiation of a wide range of abnormal responses.
So this is again showing how the AGEs are facilitating the atherosclerotic process by bringing and recruiting the monocytes from the immune system into the intima of the coronary artery. So going all the way back to lesson number 2, and how they can help speed up or facilitate the progression of atherosclerosis.
The cells and tissues, such as inappropriate expression of growth factors, alteration of growth dynamics, accumulation of extracellular matrices, promotion of vasoregulatory dysfunction, and initiation of death pathways. In renal failure patients, chronic inflammation will create high levels of oxidative stress, which will lead to rapid AGE formation. Meanwhile, the ability to eliminate degraded AGEs is compromised due to kidney failure. As a result, patients are at risk for the consequential onset of cardiovascular comorbidity and mortality.
All right, so that was the role of AGEs in disease development. Now we're going to move on to how AGEs can be measured, at least one way they can be measured. All right, so this is one way in which AGEs can be measured through this device, or can be measured through a blood draw as well.
The AGE reader is a proprietary medical device which can non-invasively assess the tissue accumulation of AGEs within 30 seconds. The result of its measurement enables an immediate risk prediction for cardiovascular risks in real time. Since AGEs lead to malfunctioning proteins, several of them have characteristic autofluorescence properties. Once they are excited by UV light, they will emit fluorescence in particular wavelengths. Powered with a proprietary technology, the AGE reader features a UV light source. Once it is turned on, the UV light will penetrate the dermal layer to a depth of about 1 millimeter, and this will trigger the AGEs under the skin to emit autofluorescence. The emitted autofluorescence is detected by the AGE reader, and the intensity of the fluorescence in particular wavelengths of AGEs will correlate to the quantity of AGEs in the tissue. In a normal person, this fluorescence is moderate, while in diabetic patients, for example, the high AGE level will result in higher fluorescence, which leads to the conclusion of increased cardiovascular risk.
All right, so that was a few videos that gave an overview of AGEs and how they're formed, the cause of disease, and how they can be measured. You can actually consume exogenous glycation, the AGEs, in our foods that we eat. Foods with significant browning or caramelization or with directly added AGEs can have high amounts of pro-inflammatory and disease-initiating compounds. So think of foods that are donuts, barbecue meats that are under high heat, cake, browning of food, dark-colored sodas, all have AGEs that have been added to them either directly or through the processing of the food itself. So we're essentially consuming these in our diets if we're eating these types of foods. So endogenous glycation, again, forms AGEs, which occurs in the body, again, mainly in the bloodstream. It's associated with oxidative damage that is linked to many age-related diseases, such as neuropathy, retinal disease, kidney disease. So all of these that we've talked about are touched on before. Interesting, elevated levels of AGEs also deplete nitric oxide levels, nitric oxide is used to vasodilate or expand our blood vessels to allow for better blood flow. But AGEs actually deplete this nitric oxide level, which promotes vascular damage and it can increase the risk of heart disease. Also, another thing about AGEs is that as sugar molecules bind to HDL molecules, the HDLs are blocked from binding to receptor sites in the liver. In other words, AGEs will bind to HDL, and the HDL then no longer can combine or bind to the liver to deliver that excess cholesterol that's circulating in the blood. Therefore, the liver is duped into thinking that there's a shortage of cholesterol in the body since it's not receiving any excess cholesterol from the HDL. So therefore, the liver thinks, okay, I'm going to keep manufacturing and making more and more cholesterol and depositing that extra cholesterol into the bloodstream, even when it's already high to begin with. And that's going to raise your cholesterol levels even more, thus increasing your risk of cardiovascular disease. So you can see that glycation end products here have quite a lot of negative health effects for an individual. So we did mention a little bit about reactive oxygen species. They're highly reactive chemical radicals that are generated when oxygen loses an electron. An accumulation of these reactive oxygen species can result in cell death. At low levels, it's important to know that reactive oxygen species act as a signaling molecule in various intracellular processes. In fact, a small amount of ROS is good at metabolism. So when you go out and exercise, you'll produce ROS, but it's important to have these in normal metabolism. It's when you have too many of them that it becomes a problem. So in low number, ROS is good, but when they accumulate, as they do during disease states, they can become destructive. Here's a picture of what a reactive oxygen species is. Here is an oxygen molecule, and there's 2 yellow electrons around. So you have 1, 2, 3, 4, 5, 6, 7, 8. So 8 electrons, and they're paired up. And this is just showing that a free radical is when one of those electrons is missing. So you basically have a missing electron pair. And that is when the oxygen molecule becomes hyperactive, a free radical that can cause damage throughout the body. So here's a video that kind of illustrates this. All right, so here's the video on explaining free radicals and what they do to us.
We are exposed to a variety of environmental stresses that affect our health. That exposure increases the number of free radicals in our bodies. free radicals are molecules with an unpaired electron in search of another electron. They roam freely in our bodies, seeking out and destroying our healthy cells. Left unchecked, high free radical levels have been linked to a number of diseases, including diabetes, coronary heart disease, and cancer. Much like high cholesterol, they are a warning sign of trouble down the road. While a certain amount of free radical activity in our bodies is normal, a variety of factors can lead to unsafe levels. An unhealthy diet, smoking, stress, injury, toxins, and pollutants in our air and water. In reality, the culprit is us. Fortunately, there are ways to defend our bodies against the harmful effects of free radicals. Antioxidants help our body fight back and repair itself from the inside out. They give free radicals the electron they're looking for, stabilizing them before they damage our cells. Increasing your antioxidant consumption on a daily basis has been shown to lower free radical levels and promote better health.
So that was an overview of the free radicals, and they mentioned in there antioxidants. And an antioxidant is basically a molecule that has a series of electrons that is able to give one electron to a free radical that then causes it to calm down now that it finally has a paired electron. So basically the antioxidant that we get from fruits and our vegetables helps with stabilizing or reducing the free radicals in our body. So it's important when you're working with clients, emphasizing the importance of fruits and vegetables to help increase your antioxidants in the body, which will then help reduce the number of free radicals in the body as well. All right, so this is the slide that depicts more detail as to how hyperglycemia increases advanced glycation end products and reactive oxygen species formation, leading to cardiovascular disease and diabetes. So you see all the abbreviations here, and just a couple things to note of this. You notice that here is this pathway is color-coded. There's 4 different pathways that are on this one slide, but I've tried to color-code them to make them a bit easier to follow. Also, at the same time, you will see that after the slide, you'll notice that I've kind of bunched them into various pathways. So you see the first pathway, I tried to emphasize steps 1 through 3, for example, what that indicates. And then again, steps 4 and 5, and then what happens with 6 through 10, and then finally 11 through 13. So in other words, I've tried to group these into various different pathways to make it easier for you to understand. So you have the notes, follow along with the notes, and that should help with understanding. Again, I try to summarize what each of the different pathways indicates. So also to look at this is just to orient you to, this is the blood vessel with the blood here and the glucose. This is the cell membrane, and then this is the tissue we're talking about. So keep in mind, whatever tissue we're talking about has to do with the disease that's being affected. So for example, in the green and the blue pathway, this tissue we're talking about is atherosclerosis, so it's talking about the coronary arteries, the intima of the coronary arteries. In contrast, we're talking about the various neuropathies, nephropathy, retinopathy, and arteriosclerosis. So these are all the capillary bloods, especially the opathies, the various blood vessels, the capillaries that are feeding the tissues of the body. And finally, you have in the purple pathway diabetes. So this is going to be talking about the beta cells in particular. So keep that in mind, that you understand that the various tissues of the body that we're referring to based on the pathway that we're talking about. So to begin with, we have hyperglycemia, and looking at the green pathway, that's going to form the advanced glycation end product, and that's going to then combine with the receptor of AGE. And this is going to cause an increased amount of reactive oxygen species to be formed and be recruited into the coronary artery intima. At the same time, you'll notice that this AGEs is going to affect other pathways, which we'll get to in just a little bit. But this reactive oxygen species in the coronary artery intima is going to increase some proteins, ERK and MAPK, abbreviated here, and also an increase, this is going to now cause an increase in plaque buildup in the coronary artery. And then finally, that's going to lead to atherosclerosis. So the thing to get from here is how hyperglycemia, sugar, basically leads to the buildup of atherosclerosis plaque, fat. It's the linkage between the two. The second pathway is the blue pathway. We're still working on atherosclerosis, but you notice that hyperglycemia is now going to be affecting the mitochondria within the coronary artery intima. Well, this hyperglycemia is going to cause the mitochondria to produce more reactive oxygen species, which is going to upregulate a protein called P38. P38 is then going to cause an increase in the monocyte adhering to the endothelial layer of the coronary artery, and then that's going to cause atherosclerosis to build up there in the coronary artery intima. Likewise, you have the mitochondria is going to produce what's called NADPH oxidase. And this oxidase, anything that ends in ASE is an enzyme that breaks down something. In this case, NADPH oxidase is going to break down NADPH. And when you have an increased amount of NADPH oxidase, that's going to then recruit increased amount of reaction oxygen species because NADPH oxidase decreases or destroys or breaks down NADPH. And when you have less NADPH or more NADPH oxidase, you have an increased amount of reactive oxygen species in the coronary artery intima, and that's going to increase P38. That should be a 38 there. But that's P38, the same protein as this one, and that's going to increase monocyte adherence within the coronary artery intima, and that's going to lead to atherosclerosis of the coronary artery intima. So the green pathway and the blue pathway deal with how hyperglycemia increases atherosclerosis in the coronary artery intima. Now we have another pathway, the red pathway, that deals with a lot of the different opathies, neuropathy, nephropathy, retinopathy, and also arteriosclerosis. But our focus is going to really be on the various opathies. So we're talking about the capillaries of the body is where this red pathway is taking effect. So we have hyperglycemia. It's going to cause what our body does when you have excess glucose. It tries to send that excess glucose through what's called the polio pathway, which is a pathway used to take glucose and make into fructose in the tissues to be used later for energy. However, in someone with hyperglycemia, that does not occur. Glucose is going to be changed into sorbitol through aldose reductase. And then that sorbitol then normally should be changed into fructose through sorbitol dehydrogenase. So sorbitol dehydrogenase. However, in a hyperglycemic state, this sorbitol dehydrogenase is stopped from activating. And therefore, sorbitol is not changed into fructose. And as a result, sorbitol builds up in the capillary blood or the capillary tissue. This sorbitol then, an increased amount of sorbitol will decrease the amount of NADPH. And when you have a decreased amount of NADPH, that increases the amount of reactive oxygen species. And in the capillaries, it's going to cause an increased amount of PI3 kinase and AKT. These proteins are going to activate the inflammatory protein NF-kappa B, and that's going to cause microvascular damage or damage to the capillaries. And damage to the capillaries over time is going to cause those capillaries to wither or die away and not allow blood flow to the various tissues, and that's going to allow or cause neuropathy, retinopathy, or nephropathy. And also in the coronary arteries, the arteriosclerosis, which is hardening of the arteries. So this is a big pathway, this red pathway that deals with the development of the various opathies of the body, and we talked about in lesson 4 when we all had all the damage to the tissues. So make sure you take a moment to understand this red pathway. Once you have a good understanding of the red pathway, We're going to move on to the final pathway, which is the purple pathway, and that's going to deal with the pancreas. Whenever you have a buildup of sorbitol in the body, that's going to cause protein kinase C to build up in the beta cells or the pancreas of the body. And a buildup of PKC in the pancreas is going to recruit reactive oxygen species to the pancreas. And this is going to cause an increase in the inflammatory protein junk. And increased junk is going to cause the destruction of beta cells, or at the very least cause the beta cells to stop producing insulin. And when you have less insulin circulating in the blood, that's going to cause an increase in hyperglycemia and eventually diabetes. So the purple pathway deals with the cause of how hyperglycemia can lead to destruction of the beta cell themselves, leading to diabetes, which is going to lead to hyperglycemia, and you can see that a vicious cycle has ensued. So this is a very important pathway, making sure that you have a good understanding of the 4 different pathways. Again, I've color-coded them to make it a little bit easier. You can refer to Blackboard to practice and put these in proper order until you have a good understanding of them, and also putting them in on your own words and comparing these steps with what we have in the notes. Once you have a good understanding of this, then you can do the thinking review questions that are here. And then what would happen to disease risk? So again, you need to list the specific disease and whether or not it will increase or decrease given the following scenarios. So I will put on Blackboard in a separate video and file the explanation. Will go through how the answers to these 5 thinking review questions. But make sure that you do these ahead of time before you look at the file and the video. All right, so how can you treat these hyperglycemia to help reduce AGEs and reactive oxygen species? There are some anti-hyperglycemic agents, so in other words, blood glucose lowering drugs, and the idea is to decrease the plasma glucose. The first of which is the glucosidase inhibitors, and this negative sign indicates that it causes the GI tract to reduce carbohydrate absorption, so therefore you have a decreased amount of carbohydrates that are absorbed in the small intestine, the GI tract, which is then therefore less glucose is going to be reabsorbed or taken up in the blood, and therefore reduces plasma glucose levels. You also, doctors will prescribe metformin, which is going to cause the liver to reduce liver production, or a decrease in hepatic glucose production, which is going to decrease plasma glucose levels. You also have glitazones, which are going to cause the muscle and fat to increase the glucose uptake into these tissues, which is going to decrease plasma glucose levels. You also have sulfonylureas. These are going to cause the pancreas to release insulin, and that's going to cause the liver to decrease glucose production, decreasing plasma glucose. And then also the insulin secretion is going to cause the muscle and fat to take up glucose as well, which is going to decrease plasma glucose. And finally, you have injected insulin, which is going to do the same thing, causing the liver to decrease glucose production, decrease plasma glucose, and cause the muscle and fat to take up glucose, which reduces plasma glucose. So it's important that you understand the different anti-hyperglycemic agents and what they do, and I've listed them here to kind of summarize what they do. So make sure you have a good understanding. We're going to watch a video about metformin, which is an important drug that is often prescribed in individuals with diabetes. All right, so this is a video that goes over the importance of metformin. You will have many clients that will be taking this drug as a to help with managing their blood sugar.
These videos at clearlyhealth.com.
Metformin medication reduces the amount of glucose released by your liver. When you have type 2 diabetes, your body is less responsive to insulin. Your cells cannot absorb enough glucose, causing it to build up in your bloodstream. A high blood glucose level over a long period of time can lead to serious health complications. Your body's primary source of glucose comes from the food you eat. Your liver also releases glucose. Metformin targets the liver, signaling it to slow the release of glucose. It also helps cells use the glucose available in the blood. This two-step action helps to reduce your blood glucose level.
All right, so that was just an overview of metformin. There's also, again, make sure that you have a good understanding of the different types of agents, drugs that are used to treat hyperglycemia. And finally, there's a series of videos that I'll put up on Blackboard for you to review at your leisure. That kind of goes over the things that we've talked about before in lesson 4, but just to kind of reiterate the importance of what the implication of glycation and how it can affect and cause the damage to the tissue leading to the various diseases that we've talked about before. So you'll find these on Blackboard as well. So this concludes the lesson, this part of lesson number 5 on advanced glycation end products and reactive oxygen species. Make sure that you do the practice on Blackboard, the thinking review questions, and have a good understanding of the AGEs and reactive oxygen species.